Chapter 1.2, exercises 31 through 46, page 102. Again, this is section 1.2 from the book. And going to these exercises, we're going to start with the odd number problems, 31. Exercises 29 to 34, graph the function, identify intervals on which the function is increasing, decreasing, or constant. And so here's 31. So we're going to enter this in our graphing calculator. And to do that, we get the absolute value in the tangent bar CX calculator, which is this key next to the 9, and then the second row on the left. Press enter. We get inside absolute value brackets x plus 2. Go outside the bracket. We have plus, get absolute value brackets here, x, and that's minus 1, and then minus 2. Then we graph this function, and looks like we have a switchover point here. Looks like the function is decreasing as we go from negative infinity toward negative 2, and then constant from negative 2 to 1, and then increasing from 1 to less than positive infinity. So we go back here and we'll say decreasing on. You say on, that implies that on the interval of greater than negative infinity to negative 2. And then the function value is constant on negative 2 to 1, and increasing, INC, abbreviation for increasing, on 1, infinity. Just to verify, we'll come and take a look at this. Okay, constant here. And to really verify, we can check the table here. Let's see. Oops. Push Control T. And we see the function increasing greater than 1, constant between negative 2 and 1, and then decreasing. Okay, that looks good. This is a correct answer. Box in is correct. Next odd number problem, 33. Let's graph this function. Control I. And add graph. So we put in 3 minus quantity, parentheses, x minus 1, and squared on the outside. That looks good. Go ahead and graph the function. And looks like the function is increasing from negative infinity all the way up to x equals 1. Let's go ahead and see if we have a maximum. We're going to do the menu, analyze graph, 6. We'll look for a maximum, 3. Now lower bound, left here, upper bound. So 1, 3. So our maximum is at x equals 1. So we can go back here and say increasing on negative infinity to x equals 1, and decreasing on greater than 1, less than infinity. Okay, that's problem 33. Let's go to the next odd number problem, 35. In exercises 35 to 40, determine whether the function is bounded above, bounded below, or bounded on its domain. Now, bounded means above and below, means bounded above and below. So, we have this one, y equals 32, and y equals 32, we could graph that in our calculator, but it's a whole lot easier. We should know what that looks like. If we have an x and a y here, we know up here at y equals 32, there is this function is a horizontal line. And basically, this is a constant function. It's constant on the interval of greater than negative infinity, less than infinity, and this function is bounded below because the boundary is 32, and bounded above because that upper boundary is 32. So we say this function is bounded because the function is bounded above and below. Okay. Next, we go to the next item problem. Y equals 2 to the power of x. We haven't looked at the parent function of precalculus yet, but this is an exponential function, which you have the base here. This is our base, which is 2. And if we have, basically the function looks like this. Hope you remember something of this from Algebra 2 last year. And we have right here at 1, go to 2. If we put in, we have xy here. If we put in x equals -1, we have 2 to the power of -1, which equals 1 over 2, 1/2. If we plug in 0 for x, we have 2 to the 0 power. Well, anything to 0 power is 1, so 0, 1. If we put in 1 for x, we have 2 to the first power. Well, 2 to the power of 1 is 2. If we put in 2, we have 2 to the power of 2 is 2 squared, which is 4. So we see the function is going to be doubling in value with every successive unit. So, let's see, 2, 3, 4. So the function is like this: 1/2, 1, 1, 2, and 2, 4. So this is what our function looks like. And where is this function bounded, if anywhere? Well, the function is bounded below, because the function will never cross, as we go to the left, this x-axis. So we'll say bounded below. Okay, next odd number problem, which is 39. We have y equals the square root of quantity 1 minus x squared. So let's just graph this one. This one here has a little more complexity to it. So go to Control I. add graph. We have the square root of 1 minus x squared. I think this function is not defined for greater than 1 or less than -1 or greater than 1. So we have this function right here. So between -1 and 1. So there's a lower boundary here at the x-axis and an upper boundary at x equals 0 here. That's going to be the value y equals 1. So the function is, if we just draw this, the function is bounded below and above. So we say over the domain the function is bounded. That is our answer. Okay, exercises 41 to 46 use a graph to find all local maxima and minima and the values of x where they occur. Give values rounded to 2 decimal places. So these exercises, we're being invited to use our graphing calculator, which we will do. First for this problem 41, and we go to Control I, add graph, and we get 4 minus x plus x squared, and we graph the function, and this is what it looks like. Looks like we're going to go ahead and use we need to find out where this minimum is. And to do that, we'll go to Menu and Analyze Graph 4, and this time we'll go for minimum. We do maximum, the other one. So we go somewhere to the left. So there's a question here, lower bound. We can just press enter there, and then we go to the right somewhere, and we see that this function has a minimum of 3.75 or 3 3/4, and that minimum occurs at x equals 0.5 or 1/2. So we say minimum of 3.75, and that minimum occurs at, and I'll just put a little ampersand here, at x equals 0.5, we could have put 1/2. And that is our answer. Okay, next, we go to problem 43. We have negative x cubed plus 2x minus 3. So we go to our calculator, and I'm going to put, I'm just going to use the same page here, x cubed, negative x cubed, so negative x to the 3rd power, and plus 2x minus 3, and so here we have, we see at the left of the y-axis a local minimum, at the right of the y-axis a local maximum, and we're going to find out what they are and answer what we're being asked here. So we go to Menu, we'll go to Analyze Graph, we'll find that minimum first, and it says lower bound, right, and we go right here. So we have our minimum, this is 2 decimal places, that's going to be convenient. Our minimum of negative 4.09 at x equals negative 0.816, and to 2 decimal places that's to be negative 0.82. So we'll say we have a minimum. I'll say local minimum of negative 4.09 at x equals negative 0.82. Okay, let's go ahead to look at our calculator to be sure. Negative 0.82. Okay, looks good. Let's analyze and find that local maximum. So go to Menu, Analyze Graph, Maximum, and we look for left bound here and right bound here, and we have our maximum of negative 1 point. It's a local maximum of negative 1.91 at x equals 0.816, which is rounded off. There's 0.82 according to the instructions. So we say local max of negative 1.91 at x equals positive 0.82. So here we have a local minimum, local maximum. Back to 41. What is this minimum here? Local or absolute? Well, it happens to be absolute, but so what we can say local. Let's say local and absolute minimum. Okay, so that's going to 45. We have h of x equals x squared times the square root of quantity x plus 4. Go to our calculator. Let's see, go to tab. Go up again here. Okay, we have x squared times the square root of x plus 4, 20x plus 4. And here we have it. So I don't quite see that top up here. It looks like there's probably a local maximum up there. It looks like there's a minimum here too at x equals negative 1, negative 2, negative 3, negative 4. Let's go ahead. I'm going to raise that. Look at that window. Take window zoom. Go to 4. Window settings. I'm going to change that Y max to maybe 25. Be sure we can see that maximum. Just to help us. Okay, well that's more than enough. Anyway, let's see if we can get these. Looks like we have a local minimum. And just to be sure, let me check the tab. Oops, no. Control T. At x equals negative 4. Okay, we do have a value of 0. And at x equals 0, we have a minimum of 0. And we don't know what this maximum here. So we're going to have 3 things. I'm going to put local, I guess absolute. We'll say local minimum of 0 at x equals negative 4 and at x equals 0. Okay, so does that explain this? Yeah, we have a local, and this happens to be absolute, and minimum here and here. We just need to find this guy right here. And to do that, see menu. Oops, they're not letting me have this. let's go ahead and I'm going to put Control I. Oops. Control I. Let's see if we can graph this. Go up here. Let's graph it again. We're going to find that maximum here. And to do that, we're going to put menu, analyze graph, and we're looking for local maximum, lower bound, and upper bound right there. And the aspect is changed. So our maximum is 9.93 at an x value of 2.01. Wait a second. Something is wrong here. Let's try this again. Menu, analyze graph. Thing didn't make sense. Maximum. We go to the left here. We go to the right. This is the guy we're looking for right here. So we have a local maximum of 9.16 where x equals negative 3.2. We have 9.16 at x equals negative 3.2. So these are the exercises here. I hope this video lesson has been helpful and that you'll be able to do all the even number problems. Thanks for viewing.